Hello, class. Today I will be discussing an event in geological time known as the Triassic extinction. I will begin by introducing the continental setting of the Earth, the fauna present, and how both of these changed throughout the period. I will then use that knowledge to help explain the hypothesized causes of the extinction and what species survived the disaster. First of all, tectonic settings and how they change can affect the Earth's climate and the life that live on the Earth. That is why it is important to review the positions of the tectonic plates during the Triassic period to learn more about what type of life lived then and what happened to the majority of it. At the start of the Triassic period, there was a great supercontinent called Pangaea that was composed of all land masses in the world. Sea levels remained very low during the beginning of the period. Because the continent was so vast, it was very difficult for the ocean's cooling effects to reach the center of it. For this reason, and because Pangaea was located over the equator, most of the land and climate was dry. By the middle of the period, Pangaea was in the process of breaking apart into two. One landmass, called Gondwana, moved toward the south, was composed of South America, Africa, India, Antarctica, and Australia. The other landmass was called Laurasia, and it proceeded to move toward the north and was composed of North America and Eurasia. The breaking up of Pangaea had a couple consequences. One being that mountains formed on the west coast of North America. Another consequence is that sea levels began to rise, causing flooding in Central and South Europe, which led to rivers and lakes that helped the gymnosperm forests form. The more drastic and destructive consequence of the breaking up of Pangaea is that the mid-ocean rift formed at the bottom of the sea between the new continents, called the Tethys Sea, began experiencing massive, intense volcanic activity. With volcanic activity of this scale, enough carbon dioxide would have been introduced into the atmosphere to change it and cause destructive global warming, and the altering of the ocean's chemistry. Many scientists have linked the breaking up of Pangaea with the cause of the extinction. The Triassic period was an interesting time for life on Earth. Beginning with life in the water, coral and other reef-building organisms evolved and thrived during this time. A new phytoplankton, or microscopic algae, evolved during this period, a few of which are dinoflagellates and the coccolithophorids. The former makes a great index fossil, while the latter, interestingly, used calcium carbonate in the seawater to form their skeletons. The cephalopods made a reappearance in this period, while also forming a new group of mollusk-type organism called ceratites. These replaced the previously extinct goniatites with more complex chambers and structures. Another type of mollusk, called bivalves, became a more important part of reef life and are related to the present oysters and clams. So as you can see, there was a lot of evolving going on in the seas. Gymnosperm forests dominated the plant life during the Triassic period. Cycads became the prominent species in the forests, making up about 20% of the plant life on Earth during the time, and continued to dominate throughout the Mesozoic. Another important plant in these forests were the ancestors of the modern ginkgo, which were spread worldwide just like the cycads. Another seed fern, Dicroidium, replaced the glossopterids in Gondwana by the end of the Triassic. The terrestrial animal life underwent a much more interesting change during the Triassic period. This period marked the dawn of the dinosaurs and mammals, which both descended from reptiles, which presented most of the animal life of the period. Therapsids dominated the continents and led to mammals by the end of the period. These mammals were small and played an extremely restricted role in the ecosystems. They were either herbivores or carnivores and had some hair, as well as body heat. Modern turtles descended from some teethed animals that appeared at the time. Another group that made the transition from sea to land during the Triassic are the Eurapsids, and they split into 3 groups by the time of the extinction. The ichthyosaurs probably evolved into modern dolphins, as that is what they appeared to be at the time. The placodonts were awkward paddle-finned animals, and they became extinct by the end of the Triassic. And then the nothosaurs were long-necked ocean predators. Other reptiles, known as the diapsids, became more abundant and important later in the Triassic. They are called diapsids because they have 2 holes behind their eyes and their skull. The main group of the diapsids are known as the archosaurs, which gave rise to modern birds and crocodiles. There were other reptiles, like phytosaurs, however, that evolved into crocodiles during the Triassic. These crocodiles occupied the phytosaurs' role in the ecosystem after the phytosaurs were extinct at the end of the Triassic. The first true dinosaur, called the Ceratosaurian, had many bird-like features. Due to the circumstances of the extinction, there is much debate on the cause of the extinction. Many scientists believe that it was the violent volcanic activity occurring in such a short amount of time from the breakup of Pangaea that set off the event, while many find flaws in that theory and accredit the extinction to an asteroid impact. Either situation would then cause the release of harmful chemicals, aerosols, and carbon dioxide into the atmosphere, causing a greenhouse effect, darker atmospheres, and a hindering of photosynthesis, stillness of oceans, a lack of oxygen in oceans and lakes. The chemistry of the atmosphere as well as the oceans were affected, causing most of the current forms of life to die off. There is little to no evidence thus far proving that the extinction had an extraterrestrial cause, but it has also been difficult to prove that the volcanic activity from the mid-ocean ridge happened in a short enough time to cause the extinction. Some believe that the timing of the volcanic activity was coincidental. It is known that there was an increase in atmospheric carbon dioxide levels due to a decrease in the amount of stromata on the fossils of ginkgo leaves. The stromata are openings that gases exchange through for plant cells. In other words, it's CO2 that enters the stromata as oxygen and water leave the stromata. So, a lower density of the openings for this shows that there was more CO2 entering the cells, so less openings were needed. This proves the high levels of CO2. Carbon testing for the age of volcanic ash reveal that volcanic activity could have been the cause, but scientists need to be able to prove that it all occurred in a couple tens of thousands of years rather than over a couple millions of years, which wouldn't have an effect nearly as great as a mass extinction. Most marine invertebrates suffered major losses, but were not completely wiped out by the extinction. This includes brachiopods, shelled cephalopods, sponges, and corals. Animals to go extinct include phytosaurs, certain groups of large amphibians, conodonts, and marine reptiles, not including ichthyosaurs, which were the ones originating dolphins. More species that took a hit in their diversity include thecodonts, brachiopods, gastropods, mollusks, and synapsids. Overall, the Triassic extinction had a major effect on most areas of life. It affected life on land, it affected plant life, it affected life in the ocean, because whatever caused this extinction changed the chemistry of almost everything. So it was very rare for something to survive. And that's what led to mammals and the dinosaurs and many of the fern life that we have today.